Hello everyone, welcome to this short lecture on MQTT protocol. In this short lecture I will introduce you to one of the most common protocols used in IoT applications or for IoT devices. MQTT stands for Messaging Queue Telemetry Transport or MQ Telemetry Transport. It is a publish, subscribe, simple and lightweight messaging protocol. The design principles are to minimize network bandwidth and device resource requirements. These principles also turn out to make the protocol ideal for emerging machine-to-machine or device-to-device or Internet of Things world of connected device, and also for mobile applications where bandwidth and battery power are highly important. MQTT was invented by Andy Stanford from IBM and Arlen Nipper from Eurotech in 1999. The latest version of MQTT is v5.0. So how MQTT works? This shows a basic working principle for MQTT. As I mentioned earlier, it is a lightweight publish and subscribe system where you can publish and receive messages as a client. So you can send a command with a client like Node-RED or any other platform to control an output, or you can send data from a sensor and publish it to a client like Node-RED or any other platform. MQTT in this case is useful because it's very lightweight and take minimum bandwidth, thus ensure high latency. There are some basic concepts that are related to MQTT. For example, publish, subscribe or pub/sub, that's the most common protocol, or the MQTT is mostly known for. So the MQTT protocol is based on this principle of publishing messages and subscribing to topics. This is known as pub/sub, where multiple clients connect to a broker and subscribe to topics that they are interested in. Clients can also connect to the broker and public messages to topics. So what is topics? I will come after. Many clients can subscribe to the same topics and do with the information that they want or whatever they want. For example, in this case, device 1 publishes on a topic, device 2 is subscribed to the same topic as device 1 is publishing in, so device 2 is receiving the messages of that topic. So as we are talking about topic, what are the topics? So topics are another important concept in MQTT. Topics are the way you register your interest for incoming messages, or how you specify where you want to publish the message. Topics are represented with strings separated by a forward slash, and each forward slash indicates a topic level. In this case, for example, you have sensors, then you have the computer name from which you are reading the temperature of an hard drive. So here the sensors, the computer name, the topic and the hard drive name all are different level of topics, and the forward slash is representing here the hierarchy. You can add or join multiple topics using two wildcards or two operators. Those are known wildcards in MQTT. One is the plus sign or hash symbol. Plus can be used as a wildcard for a single level of hierarchy, whereas hash or hashtag can be used as a wildcard for the remaining level of hierarchy. In most of the cases, we use plus wildcards. Then there is another concept in MQTT, that is the quality of service. So MQTT defines 3 levels of quality of service, that is 0, 1 and 2. In case of 0, client or broker will deliver the message, but you don't receive or send any confirmation. In the level of 1, client or broker will deliver a message and the confirmation will be required, or a notification that the message is delivered. At the highest level of quality of service, or QoS, the broker or client will deliver the message exactly once, but there is a more thorough process, so authenticating each other using a 4-step handshake. Then we have the messages concept in MQTT. So messages are the information that you want to exchange between your devices. It can be a command or it can be a data itself. Another important concept in MQTT is brokers. So the broker is primarily responsible for receiving all messages, filtering the messages, decide who is interested in them, and then publishing the message to all subscribed clients. In this case, for example, the broker works as a post office where multiple clients or devices are sending the message. In this case, we can think messages as letters, and then the broker as a post office send those messages or letters to designated clients or devices. A broker is a software running on a computer. It can also can be a cloud application. The broker works as a post office, so the MQTT does not use the address of the intended recipient, but uses the subject line called topic, and anyone who wants to copy of that message will subscribe to that topic. Multiple clients can receive the message from a single broker, that is one-to-many capability. So we have one broker and multiple clients. Similarly, it can be the opposite. So multiple publishers can publish topics to a single broker. Each client can both produce and receive data by both publishing and subscribing. So at the end, it's basically a many-to-many clients relationship or communication. With MQTT broker architecture, the devices and application become decoupled more and more secure. MQTT use some encryption because it might have some username or password for the connection. The broker can also store the data in the form of retained messages. So whatever message it receives, it is stored in the same way, and it does this so that new subscribers to the topic can get the latest value straight away. Broker also keeps track of all the session information as the devices go on and off, and which is known as persistent session. There are multiple brokers. Some of them are proprietary, some of them are open source. There are also cloud brokers. One of the very common broker is Mosquito, which is an open source message broker that implements the MQTT protocol versions 5.0, 3.1.1 and other previous versions like 3.1. And Mosquito is lightweight and is suitable for use on all devices from low power single board computers to full servers. There are also the cloud MQTT that is also highly used for the IoT applications or devices because this is hosted on the cloud. I also list some public brokers that you can visit from this link. There are some design principles for MQTT. As I mentioned earlier, the MQTT is lightweight, so it must be simple, and since it is lightweight, it does not take much bandwidth in the network, and networks that has small data rate or large range like LoRa is more suitable for MQTT protocols. When you are using the MQTT for sending or receiving data or for subscribing to a topic, usually they always use a URI, and URI is a identification for a topic or for a device. In this case, we are sending data from a client device to another device or to a broker. So all the messages have this unique or common format, which includes obviously the MQTT as a schema, and it can be, for example, also HTTP for other protocols. But as I mentioned, MQTT is lightweight than HTTP, which is obviously far better for IoT applications. So this schema part or scheme part defines the protocol to use to communicate with the server. It can be MQTT, it can be also MQTTS, which is more secured for communication with the server, and then it can also include the username and password. It should also so username and password could be optional, but then it also have host and the domain, but this is the mandatory part of this URI scheme. Then we also have the port number. Usually the default port number is 1833 for MQTT, but if you are using MQTTS, then it's 8883. There are some more online resources on MQTT. If you visit this link from GitHub, they have some cool materials that you can play with, from text examples to large scale examples where how and where we should apply MQTT, or how we can apply and use MQTT in the context of IoT. But the official website for MQTT is mqtt.org, where they have a bunch of libraries and softwares that you can use for using this protocol. I hope I could best give some basic idea on MQTT. Thank you.